Hello dear students, our today's topic is phenol and its derivatives. Now the question arises that what is phenol? So phenol is this structure where a phenyl ring attached directly with hydroxyl group. So if we look at the name, this phen taken from the phen of phenyl and the ol is taken from this O and L of hydroxyl group. In this way, it will simply become phenol. Now there are various derivatives of phenol. Now let's look one by one. When two hydroxyl groups are attached, in this case, we arrive at three isomeric structures. In simple nomenclature, all compounds are called as dihydroxybenzenes. Now let's look at the first structure where the hydroxy groups are at ortho position to each other. This phenol have a name called as catechol. In this structure, the hydroxy group are at 1 and 3 position to each other. That means both the groups are at meta position to each other. This structure is called as resorcinol. The third structure, here the hydroxy groups are at 1 and 4 position to each other. That means para position to each other. This compound is called as hydroquinone. So these are the three isomers of dihydroxybenzene. Now let's look at some another structures. Suppose a methyl group is attached on phenol at various positions. Now such structures where methyl and hydroxy group are attached on benzene ring, such structures are called as methyl phenols. They have the special name. They are called as cresol. Now when the hydroxy group and the methyl group are at ortho position to each other, this is called as orthocresol. When the hydroxy and the methyl group are at meta position to each other, this is called as metacresol. Here the hydroxy group and the methyl group are at para position to each other. That means at 1 and 4 position to each other. This is called as para cresol. So these three isomers are of the phenolic compound cresol. Now move on to the next one. Suppose one more methyl group is here at this position, and suppose at this position. When two methyl groups are attached with a hydroxyl group, such structures are called as xylenols. Now if you look at the first structure, the two methyl groups are at position number 2 and 3 with respect to hydroxy. So this xylenol is called as 2,3 xylenol. Here the methyl groups are at position number 3 and at position number 4. So this is called as 3,4 xylenol. Here the two methyl groups are at position number 2 and 4 to each other. So it is called as 2,4 xylenol. So these three are the isomers of xylenols. Let's look at some special type of phenol. When here is presence of a methoxy group at ortho position to phenol. In this case, the OH is given number 1 position, so this will be number 2 position. That means the methoxy group is at ortho position with respect to the hydroxy group. This special structure is called as guaiacol. Next we are moving on to the two isomeric naphthols. Let's look at these two structures. Both the structures are isomers of each other. In this case, the hydroxyl groups are attached with naphthalene, so they are called as naphthals. So this is a naphthol and this is also a naphthol. Now this is structure where the hydroxyl group is attached on the carbon which is just adjacent to the bond common to both the benzene rings. This is the bond which is common to both the rings. So this is the adjacent position. This is also adjacent position. So when the hydroxy group is directly linked with this adjacent position, it is simply called as alpha naphthol. It is also considered as 1 naphthol. Now in this case, the hydroxyl group is present at this position. This position is called as position number beta. It is also called as position number 2. So simply this will be beta naphthol, or you may call it 2 naphthol. So by looking at this structure, we can differentiate between the alpha naphthol and the beta naphthol. In case of alpha naphthol, the hydroxyl group is attached on the carbon adjacent to the common bond, while here the hydroxyl group is on the position which is next to position number 1. So these two are the isomers of naphthol. Let's look at another structure. In this structure, the hydroxyl group is attached with this ring system where 3 benzene rings are attached with each other. This ring system is called as anthracene. So hydroxyl group is attached on anthracene, so it is called as anthracene all. The hydroxyl group is present at position number 10 in this condition. So this structure is called as anthracene 10 all. Next we will move on to some trihydroxy compounds. For example, this one where the hydroxyl groups are at 1, 2 and 3 position to each other. Here all the hydroxyl groups, the 3 hydroxyl groups are adjacent to each other. Such structure is called as pyrogalol. When the hydroxyl group are at position number 1, 2 and 3, it will be simply called as 1, 2, 3 trihydroxybenzene, which in general name is called as pyrogalol. When the hydroxyl groups are at 1, 3 and 5 position to each other, this trihydroxy compound is called as fluoroglucinol. If the hydroxyl groups are at position number 1, 2 and 4, it is called as 1,2,4 trihydroxybenzene, and its general name is hydroxyquinol. So these 3 were the examples of trihydroxybenzenes: the pyrogalol, fluoroglucinol and the 1,2,4 derivative hydroxyquinol. Now beside this we have some very important phenolic derivatives. For example, if on phenol there is presence of an aldehyde group at ortho position to each other, such structure have a special name, and this is called as salicyldehyde. Here you may find the difference that the previous compounds were called as phenols, while this compound is called as aldehyde. Here again we have 2 functional groups, the hydroxyl group and the aldehyde group. And as I have told you earlier in my previous video that as per the priority order, the aldehydes have priority or superiority over the hydroxyl group. That's why the name of this phenolic derivative will be salicyldehyde. Now suppose a carboxyl group is present with phenol. Such compounds also have a special name, and this is called as salicylic acid. Once again, we didn't call it phenol, we call it acid because the carboxylic acid have the superiority over the hydroxyl group. So these are the introduction of some very important phenolic compounds. Thanks for watching the video. Please like it, share it, and don't forget to subscribe. Thank you.